So let's go through some examples. Potential energy. Let's start with this one. So this is the potential to do something. Well, you all know that if something is lifted up high, it has the potential to fall, because gravity will pull it towards the earth, and as it's being pulled, it's actually starting to speed up, and that pull gives that object motion, speed, falling down to the earth. But before you have that speed building up as it falls down, you've got to push it up so it can fall. And when you put something up high and give it the potential to fall, we call that gravitational potential energy, because you have the potential to move because of your position relative to the earth. Another one is the chemical bonds that are in our body. Now these ones are all the atoms around us. They don't like being put together, and the only way that they are held together is because they have little bonds of energy that hold them together. And each one of these little bonds of energy is stored energy. Now, on its own it doesn't do anything, but if you break a bond, you release a whole heap of energy out of that. And we often see that in the cases where we're burning stuff. You are actually releasing the energy that's holding whatever you're burning, say it's wood. You're releasing those chemical bonds, and that energy then comes out, and you see it in different forms. You'll see light and you'll see heat. That's actually the energy being released from those chemical bonds in the wood as you burn it. So we actually have the potential inside us for a lot of chemical potential energy, because it's the energy that's literally gluing us together. Elastic potential energy is really fun, because you know that if you stretch a rubber band, something's going to go twang and move really, really well, depending on how well you've stretched your rubber band. That's because atoms between us, inside us, or in the real world, some of them are held together, but that little bond there, you can actually stretch it out a little bit, but it doesn't like being stretched. And if you stretch it out, put energy into it, pull it out, stretch it out, that's fine. But as soon as you let it go, it's going to come back together again, because they don't like being so far apart. So that's electrical potential energy. That's where the bonds are stretched out beyond where they're comfortable. And as soon as you let them go, those bonds between those atoms pull back together, and they release some energy when they do that. So notice every time I say that we're releasing energy, it's because energy's actually been put in to begin with. This is stored energy here between those bonds. We had to put energy into them to make those bonds. When you think about the energy that's in you, we had to put energy in to build you up. And that's in the food that you eat. That energy has been put into your atoms to put them into a certain formation and store them in you. And when they break apart, that energy is released again. Elastic potential energy, we put energy in to pull them apart. And as soon as we release them, they fall back together again, and that energy we put in is released again. Now, the last two types I'm going to tell you about are nuclear and magnetic. Now, nuclear is hard for us to understand because we haven't really got into it, but basically think nuclear explosion. Now, your atoms, like I told you, are there, and they don't want to be together. They really enjoy it if you just let them move around, but we actually hold them together with bonds. Well, inside this atom here is little particles that are even more eager to be broken apart. So inside that atom there, if you look inside it, it has little particles in here that are dying to break apart. They really don't want to be stuck inside the atom, but they have to be, because that's how an atom is formed. And the amount of energy that holds these guys together in there, in the nucleus of the atom, and we're going to be looking at that in chemistry, the amount of energy that's holding them together is huge. Think of bulls being trapped in a pen together, and all they want to do is hit heads, and as soon as you open the pen, they just go racing out and trying to get away. Well, that's what it's like inside an atom. And when you do release these little subatomic particles, there is a huge explosion. A small amount of atoms causes a huge explosion. We know it as a nuclear reaction, okay, like a hydrogen bomb. So the amount of energy that's actually holding our own atoms together is huge. You break them apart, you have a lot of energy released. The last one is magnetic energy that we're going to talk about. This is the pull between atoms. Believe it or not, all of your atoms, they actually pull to each other. They have an attraction between them. And that attraction means that they actually can store energy in that attraction. And you know that if you put a magnet near another magnet, you'll feel them pulling towards each other. So when you have magnetic potential energy, there is the potential there to pull other atoms towards it because of the energy of that pull. Okay, let's go over to kinetic energy. Now this, it's easier to talk about it in the basic types. Remember how I said you can have things moving, you can have things vibrating, and you can have things spinning, which we often call moving as well, just round and round and round. That's called motion energy when it's moving, spinning, or moving from one place to another. We call that motion energy, but often, including in your own textbook, that motion energy is talked about as kinetic energy. But if it's kinetic energy with something moving from one place to another, then you've got motion energy. Heat energy. Heat, people don't realize, is actually a kinetic energy. It's actually something that's happening and is energy that's doing something right then. That's because all of your atoms around you are actually vibrating with energy. This is how we draw it. And that vibration is literally a movement, and we sense it as heat or temperature. Okay? Everything around you is vibrating. That's hard for you to understand, but it is. Everything around you is vibrating with heat. You have to go several hundred degrees below zero before you actually get to a point where atoms stop vibrating. There is heat radiating off everything around you. Sound energy is basically atoms bumping into atoms as you talk, and your eardrums pick this up. So sound energy is actually the movement of the atoms bouncing through the air as they move because you are producing sound. Light energy is a wave. And this is radiation energy. And this stuff can actually travel through space. This is why it's so important, light energy. Because in space we have no atoms. In the vacuum of space, there's nothing there to hold the energy. The only way that the light gets to us from the sun to Earth is it travels as a wave until it gets to our Earth. So light energy travels as a wave. And lastly, you have electrical energy. Now, unless you know a little bit about electricity, this is confusing. Electricity is literally the movement of electrons. Remember I said that we have these atoms over here, and they're held together with lots of energy, and these guys really don't want to stay inside, but they have to. Well, on the outside of atoms, we have these little things called electrons, and they're spinning around the atom over and over and over. Well, sometimes they can actually move as a group in a certain direction, and when they do, we call this electricity, because electricity is the movement of electrons through something. And because they're moving, of course, it's kinetic energy. So they're the basic types of energy that you're going to be dealing with.